Picture yourself strapping into a spacecraft with a destination unlike any in human history, Mars. Now imagine knowing, deep down, that once you leave Earth, you may never truly belong here again. It sounds like the plot of a sci-fi thriller, but according to current science, this is a very real possibility. The harsh truth isn't that we lack powerful rockets or advanced engineering. The real obstacle is far more intimate and unsettling. It's the human body itself. Traveling to Mars is not just a journey through space. It is a journey into conditions the human body was never designed to endure. While humanity reached the moon in just a few days, a trip to Mars stretches between 6 and 9 months one way. That means astronauts would spend at least 2 to 3 years away from Earth before even considering a return. And during that time, every system in their body would be pushed beyond anything evolution ever prepared them for. Distance alone makes this mission unforgiving. At its closest, Mars is about 55 million kilometers away. Communication with Earth isn't instant. Messages take over 20 minutes to travel one way. In a crisis, there is no rescue mission, no emergency evacuation, no nearby hospital. If something goes wrong, help is months away. For the first time in human history, astronauts would truly be on their own. But the real story isn't just about distance or isolation. It's about transformation. Over the course of a Mars mission, the human body experiences 3 entirely different gravitational environments. First comes complete weightlessness during the long journey through space. Then comes Mars itself, where gravity is only about 38% of what we experience on Earth. And if a return is attempted, the body must suddenly readapt to full Earth gravity. These shifts are not minor adjustments. They are extreme physiological shocks, layered over years. The human body is finely tuned for life on Earth. Remove it from that environment, and it begins to change. Slowly at first, then more dramatically, and eventually in ways that may not be reversible. Even astronauts who spend just 6 months aboard the International Space Station often struggle to walk when they return. Their muscles weaken, their bones lose density, and their cardiovascular system declines. And that's with Earth just 400 kilometers away and constant medical support available. A Mars mission multiplies these effects. Time and space is longer, conditions are harsher, and recovery is uncertain. Scientists already know enough to be concerned. The body doesn't simply adapt. It deteriorates in ways that could make a return to Earth dangerous or even impossible. One of the most invisible yet dangerous threats is cosmic radiation. On Earth, we are shielded by the planet's magnetic field and atmosphere, which block the vast majority of harmful radiation. In deep space, that protection disappears. Astronauts would be exposed to radiation levels hundreds of times higher than what we experience on Earth. Over the course of a Mars mission, this exposure could equal hundreds of CT scans or thousands of X-rays. The consequences are severe. DNA damage accumulates, increasing cancer risk significantly. The cardiovascular system ages prematurely, with blood vessels and arteries becoming damaged. Even more alarming, the brain is affected. Cognitive decline, slower thinking, and memory issues can develop, potentially becoming permanent. The eyes are not spared either, with an increased likelihood of early cataracts. Meanwhile, the immune system weakens, leaving the body more vulnerable to disease. Efforts to shield astronauts from this radiation have limitations. Thick protective materials can sometimes make the problem worse by creating secondary radiation. So while radiation quietly works at the cellular level, another process unfolds more visibly. one that directly impacts strength, mobility, and survival. In the absence of gravity, the body begins to break down in a way that resembles accelerated aging. On Earth, gravity constantly challenges our bones and muscles. Every movement we make reinforces strength. Remove that force, and the body starts to dismantle what it no longer thinks it needs. Astronauts in microgravity lose about 1 to 3% of their bone mass every month. Over time, this becomes staggering. After a year, bone density loss can reach levels comparable to severe osteoporosis. Over the course of a Mars mission, this loss could exceed 50%. Bones that once supported a healthy adult could resemble those of someone decades older with serious medical conditions. The most affected areas are the hips, spine, and legs, exactly the parts of the body needed to stand and move under Earth's gravity. At the same time, calcium released from weakening bones can lead to kidney stones, adding another layer of risk. Muscles follow a similar pattern. Without gravity, they are no longer required to work as hard, and they begin to shrink. Strength fades, endurance drops, and muscle fibers themselves change in composition. Tasks that once felt effortless, like walking or climbing stairs, can become exhausting challenges. Even with strict exercise routines, astronauts cannot fully prevent this decline. They can only slow it. And the longer the mission lasts, the more profound the changes become. By the time astronauts complete the outbound journey and spend months on Mars, their bodies are already deeply altered, and the story is only halfway finished. As the mission continues, the transformation of the human body reaches deeper levels, affecting not just strength and structure, but the very systems that keep us alive. While bones grow fragile and muscles waste away, another critical organ quietly adapts in a way that could make returning to Earth extremely dangerous: the heart. On Earth, the heart works constantly against gravity, pushing blood upward to the brain